Ladies and gentlemen, today I made something useless. But Randomonium, you ask. Useless, you ask. Did you make a clone of yourself, you ask? No. He's quite useful. But now seriously, with all the seriousness that's going on in the world, I decided, by the way, that's not a topic I'm going to be touching with a 39.5-foot pole, but I decided that I'd take this moment to do something a little less serious and have a little fun on the channel while learning a new skill. So I made this. Let's begin. Ladies and gentlemen, I present to you the 7 parts that make up my very first attempt to take something from 3D CAD software to a 3D printed, real-life tangible part. Introducing the Why Do I Exist 9000. Why is it named the Why Do I Exist 9000? Well, because it's about as useful as a washing machine in a nudist colony. I don't even care, I'm leaving that in. And if you don't understand how they all work together, that's alright, because at the end of this, I'll show you how to put it together and I'll explain how this whole thing works. Alright, so the parts are as follows. First we have the paper take-up tube, which fits on the outside of the crank loosely with 2 slots to grab the paper when you start twisting. Next you have the crank itself. Very self-explanatory, fits through the holes in the main body, and it has an indentation on one end so that a retainer clip holds it in place. Next we have the paper feed drum, and this is what sits on the bottom of the main body, and it contains our programmed music sheet, and dispenses it out of this slot here. We have a 3D printed C-clip, which fits on the end of the crank. We have a flat 10-hole bar, and those holes line up with the holes in the harmonica and the main body. And basically what this does is it gives us a flat surface to put a sealing fabric on, in our case felt, so the paper can sit up against it, between this and the main body. And on the other side of this is the manifold, which you blow air through, and it divides it up between these 10 holes. This is the manifold. You simply blow on that end of the straw, and then the air is divided between those 10 holes. Next we have the main body. This is what all of our parts will mount onto. This is obviously what you hold, and this is also the part that holds the harmonica right in that little crib right there. You have clips on either end that hold the harmonica in place, and hopefully firmly against that surface right here. And this is the surface that our paper will roll against, so we'll probably need to take some sandpaper and smooth that down as the first thing we do. You'll want to get this as smooth as you can because this will be the only sealing surface between our paper that will be rolling over the top of this and of course the plastic. So making sure that all of our air gets into a harmonica is very important. Alright, now we can start putting the whole thing together. I'm right-handed, so I'm going to put this on the right side. And then place the retaining clip. Just like so. And now our paper drum simply lines up and snaps in place like so. Alright, now we'll be needing some super glue. And we're going to put some on the surface of the mouthpiece or the manifold, making sure that we get even fluid coverage all around the edge so that we don't have any air leaks. And then this gets pressed onto our reader bar. Now that that's dry, it's going to be glued exactly in line with this. Now it's very important here to make sure that the holes line up so that we get proper function. Just like that. This thing looks ridiculous. Alright, so we've got this, but of course, we have our main piece right here. And this was modeled to accept a Fender Blues Deluxe harmonica. Just a cheap one from Amazon, but it works. Well, you know what? Doesn't matter. Don't even care. As long as we have one. So our harmonica is in place, held fairly tightly, as you can see, and blow through a nozzle, we get roughly evenly distributed air between all of these, even with no paper there. So the next step, obviously we can't make a perfect gap here. That's the exact width of our paper, and so we can't make a good seal. For that, I have some black felt fabric. I'm going to cut something of a gasket out of this to use for butting up against our paper and the plastic surface on this side here. The next thing to do is make a sheet of paper that's the size that fits in there and then program it. So for that, ta-da! So our entire feed system is set up to use 3 1/4 inch wide paper. And so I'm just going to start cutting a long strip of this, which is just a sketch pad, so it's slightly larger than your normal paper. Wow, surprise, surprise. Probably couldn't have guessed, huh? Now just for demonstration's sake, I'm going to go ahead and feed it into the device just so we're all super crystal clear. Alright, this is our device, this is our paper. Feed it in like so. And then of course it expands inside the tube. And as you can see, there's a notch here in the paper tube that's a little bit further indented than the slot that you slide the paper into. And that's to keep it centered inside of the tube and thus inside of your manifold here. Perfect. Just like that. And this roller up here has a slot in it, as you can see, and the crankshaft has a corresponding slot, as you can see. And so what happens is, when you feed the paper into here, making sure that both slots are aligned, as soon as you start to turn the crank, it creates a pinch point, because of course this does not want to move, but this does. And so it starts taking up the paper, and the felt applies tension, and it feeds it right across that bar. Done. So the next step is quite simple. To program the music, we're going to draw 10 lines onto our sheet music, and then each one of those lines will represent a note on the harmonica or a hole, and it'll allow air to flow through the paper into the corresponding hole, playing the note. You know, it'd be nice if they made, I don't know, square ruled paper with lots of 1/4 inch segments that are already printed into perfect squares, wouldn't it? Somebody should invent that. I've left a 2-inch gap on one side just because there will always be a bit of paper running from the reader bar up into the take-up spool, so it isn't necessary to have any notes there, and of course if we started a song there we would end up further down anyway, so it would make sense. Anyway, that's our sheet music. Now time to just punch holes, I guess. This will just be arbitrary holes just to test the apparatus and to see how it works. So we'll do some scales and see whatever else we can think of. Alright, so we have our scale. Don't even worry about it. Anyway, now this device allows us to do some things that we can't ordinarily do, or is very difficult to do with a traditional harmonica, being that we can play 2 notes that are far apart at the same time. So I'm going to try to exercise that a little bit throughout here and just try some things, I guess. It works. Well, it does work now. The flannel gasket was certainly an improvement, but I have another improvement in mind. For the music, I'm going to be using freezer paper. Well, A, it's on a long roll, of course, and it's also plastic coated, which means it'll slide through our gasket and our plastic quite easily. So I'm going to throw together a quick, simple, easy song. So on a quick note, if you're not familiar with how harmonica music works, essentially each hole has a number 1 through 10, and the music will be laid out with simple numbers in the order that you should either blow, or if they have a minus sign next to it, it means you need to draw air in, and it'll play a different note. Also, while I have my phone out, if you're interested in following my Instagram account, Rando_Monium, I post random things there every so often, so if you'd like updates or just more content, feel free to take a look. time I thought I'd experiment with some elongated notes just to see if I could get something that lasts longer without just pausing, because obviously a constant output of the human is really desired. That way the machine really does the work. That's all the time I'd have for today, but I don't want to leave this project where it is. I didn't really do much for songs, so what I think I'll do is, if there's enough interest and you want to see more of this, then leave a comment. And if I get enough, then I'll think about doing maybe some more complicated, intricate songs. Maybe a whole video just dedicated to some stupid harmonica songs. Also, and if there's enough interest in making it and 3D printing one for yourself, then I'll be happy to upload the STL files to Thingiverse or some other 3D printing sharing platform. And if you like the lighthearted video and the lighthearted small projects every now and then, be sure to let me know. And if you liked the video, hit the like button. If you didn't, hit the like button. Subscribe if you want to see more of my projects, and I hope you enjoyed watching this video as much as I enjoyed making it. Take care.